Hi guys, welcome to Learn Electronics Repair. I have 3 amplifiers here. These are from active speakers, DEA, K-15A. Yeah, I know it's upside down, but for the Australian viewers you can read that perfectly. Yeah, 450 watt power, full range. So these are full range cabinets. They may have bi-amp on these, so 2 amplifiers, one for the horn and one for the woofer, or it may actually use a passive crossover on the speaker. We'll find out, no doubt. So the fault is that he tells me is one doesn't start. I think it's one that doesn't start. It was a typo. It said done and it didn't translate. I bet it's 1 doesn't start and 2 go into protection. So that's the fault we have. Okay, I usually like to make some basic checks if I can, or at least have a look to see what we have here before we fire them up. So we'll take a look, we'll mark them 1, 2 and 3 so we know what's what. And I also have, because the guy was so kind as to give me, a PowerCon cable. I didn't have any PowerCon cables. So this fits into here. This looks like a speak-on connector, yeah, but it's not a speak-on. This is a speak-on cable. And you cannot plug that into there, okay? It will not go. This is a PowerCon. Yeah, same principle, just for mains power. Okay, let's see. So I'll just take a look at one. Let's figure out what we actually have here, what sort of topology, what these things are, and then we'll take it from there. Okay, so it looks like we have a 450 watt amplifier, which interestingly has a 350 watt transformer. So I'm not really sure where the other 100 watts come from. I can see on here some markings. So we have a plus and minus 36 volt and a plus and minus 60 volt supply. Okay, I'm just looking at this now, and from what I can see, it's going to be difficult to work on because everything's kind of like underneath there. Okay, these devices are bolted or screwed into the heatsink. You can see the other end of the pins there, yeah, and they're all soldered along here as far as I can see on the edge of this board. So this is effectively the power supply board. This is the amplifier, and I think it's 2 amplifiers. So if we look here, we have power coming in here. Okay, and I think this is the initial look. We have 3 large devices down there, and we have 3 more large devices down here. Okay, this could be, assuming it's a class AB, the NPN and PNP side of the amplifier. So this effectively forms one amplifier. You can see like there's a 100 ohm resistor here, another one here. It's kind of symmetrical looking, yeah. This is the protection circuitry, and then we have the connections here to the 2 speakers. So that means that the crossover is on here. It's active, which means there are 2 amplifiers, one for the bass and one for the treble. And we look here, we see another set of wires coming into this area. And if I look down under here, maybe with a torch, it looks like we have 2 more smaller output devices. You see them there? Okay, and there and there. So I think probably this forms another amplifier, class AB again, and this is the lower powered amplifier that drives the horn. And then this bit of circuitry at the end here, I think probably is generating the plus and minus 15 that supply the little mixer board. That's the normal voltage you would find. There's 2 capacitors there, there's a couple of power resistors. There's probably some sort of voltage regulators, but I don't really see them. And they would, I would think, generate the plus and minus 15 from the plus and minus 35. So that's what I think I have. It looks like I can probably take this PCB off fairly easy-ish. Okay, and then I can get more to this amplifier, and I'll probably have to unsolder all of the power devices to get this board off. Okay, it's not easy to get to anything much at the moment, but what I think I can at least do is look for shorts around these power devices on here. Okay, so these two I think are for the tweeter, and then we have sets of two sets of three for the woofer. Okay, so if I can get that off, I can probably measure to at least see what we have there. Okay, looking for shorts. I may as well power these up. I'll put the current limiter on. These is one is dead, two have protection mode. So let's try that and let's see what they actually do. So this one, we have the light bulb up there. You can see it's set to limit at the moment. I'm going to switch this on and let's see what it does. Bright and then goes dim. That's what you'd expect. And this one is coming on. So I'm going to switch off the bulb, power it up, and let's have a look at the lights here. So power is on. This is not in protect mode at all. Okay, interesting. So that doesn't really do what he says, unless this is the one that doesn't start. Okay. So this one is blue LED on. Okay. We'll call it number one because I might end up swapping stuff around on these. So this is number one. This is, can we find somewhere? Yeah. Number one. Okay. And somewhere on here. This is number one. Again, I've put the light bulb onto limit. Connect it up, switch it on. What does this one do? So this one's just blue as well. Okay. Blue on. This is number two. And lastly, this one. So I have the light bulb again set to limit. Does the same as the other two. Switch that off. Blue LED on. No protect, no signal, obviously. Well, they're really not doing what he said they were doing. So again, this is just number three. Blue is on. This stuff wipes off, by the way, with a little bit of isopropyl. Sweet. Okay, so we have three amplifiers which all seem to power up. Obviously there's no speakers attached, so I think the next thing to do is just check to make sure there's no DC offset voltage on either of these. Okay, I'm just trying to figure out which one is actually which, but we have these two wires. It says agudo, which is sharp, something like that. This will be the treble, I think, 8 ohm. These are also the thinner wires. These are a bit thicker. Okay, and I would say pretty much the black and red is the negative, red is positive, and then black and red for these. That sort of makes sense. Let's just connect a voltmeter and let's make sure we have no DC voltage here. If we don't, I'm going to connect a, I have some full range cabinets. You know I use them a lot here for testing, so I'm going to connect this to my speakers, the full range ones. I'm going to connect this to my little 8-inch sub, the one with the dodgy Conan, but it's okay for testing. And I'm going to power these up with speakers attached and see what they do. I've just clipped some crocodile clip leads on, so I'm on the tweeter, the sharp speaker. Yeah, strange translation that, but there you go. So let's try this. We're on volts range now. Okay, power on. Basically no voltage there. That's what we should have. Okay, just let the power drain off a little bit. Okay, and then the bass speaker. Okay, I've clipped the leads on again. What do we have? Again, basically no voltage there, practically nothing. So once again, that's what you would expect to have. I don't hear the relay clicking, by the way. I will say that now. I do not hear the relay click. Yeah. which I rather thought I might. And I didn't hear it on any of them, okay. We see the relay here. This is a double pole, looks like a double pole relay. So I'm pretty sure that breaks the connection to both the horn and the woofer. You'd sort of expect that, really. Yeah, double pole. So I thought I would hear this go click, and I don't. That may be a problem with this. Right, let's figure out how to connect up the speakers and see what this actually does. So this is to my horn speaker, although it's actually it's a jukebox speaker, 6-inch, full range cabinet thing with a tweeter and a woofer. Well, we can use that as the tweeter, okay. Now I need to do something similar with this one. I've connected up the speakers, so let's switch this on again. I've got the mixer turned down at the moment. Just the on light, let's give it a bit of drive. And we don't get any audio, okay, there's nothing coming out of this one at all. That really doesn't surprise me because I never hear the relay click. Okay, let's quickly try the other two as well. Here is number 2. Okay, what does it do? Well, the same as the other one. I also notice I have no signal, but the mixer's turned down. Let's just watch. So I still have no signal LED. I don't think I had on the other one either. Okay, I can see I have a signal on the mixer. I see the LEDs there, the VU meter. I'm going to make some basic checks on this one. So I just want to see that we have all the voltage supplies we expect. Okay, is there some supply voltage missing or something maybe? We can disconnect that. Right, let's see. We have our transformer. We have green, black, green. That's the plus and minus 35, okay? And blue, black, blue is the 60. And the blue, black, blue we can see goes down here. And the green, black, green comes along here and it goes to there. So that's the supply from the transformer. And then this will be the output. So there's going to be a bridge rectifier somewhere around here. Some big capacitors. Yeah, the bridge rectifier is actually just there. And then some of these capacitors will be on this voltage rail. So let's see. I'm thinking that this black is the same as that black, so ground is ground. Okay, just go to resistance range. Yes, that connects to there. I would have expected that. So we can look at the supply voltages. Red one down here. I can just, if I go to resistance range, if I see some resistance there, I know I have a good contact. In fact, there's a bit of voltage there, okay. So we'll go to volts range. We're going to power this up. That's the minus 49 volt supply. That's interesting, the red one's minus, but hey, I guess it could be. And the blue one is positive. Okay, unconventional, but that's what I have. Okay, so this is the plus and minus supply to the main amplifier, 84. So we should have minus 84. We do. And then I'm thinking that we will have a plus and minus 15 here. So we can see 3 wires. Okay. Let's go back to resistance range. I'm thinking, just guessing, the middle one is ground and that'll be connecting to the same as the other grounds. It does. Okay, you can see that on the meter. So again, it's the common ground. I would expect that. And then we should have a plus and minus 15. And I think the other one, maybe, is there a fan on this? Sometimes you have a 12 volt supply going somewhere. Okay, so let's have a look. That's very close. Yeah, minus 15. plus 15, close enough. And then the other one, I'll bet, is on an isolated supply, not connecting to ground. No, I could be wrong actually. So that's a 9-volt supply. I don't suppose the fuse is somewhere in the secondary side. Well, there might be some more fuses. That's possible. Could be some more fuses on this. This really should be the mains fuse. Oh, there is a fuse in, but it fell inside. That's interesting. Okay, well, it fell back out again. The fuse is intact. Let's check it anyway. Looks good. Fuse is good. Are there any other fuses? There often are on an amplifier, but I have to say I don't see any, unless it's SMD one somewhere, of course. Don't see any fuses. Okay. Is anything getting warm, or anything not getting warm at all, which might be a bit strange also? Okay. Let's have a look. So there's some things still a bit warm actually from when it was last powered up. There's a couple of resistors down here which are quite hot. Let me just switch it on again. Yeah, those things. So they are 60 degrees or something like that. 87. No, they're too hot. That's 2 resistors there. What else do we have? They are definitely too hot. 110 now, okay. So something's wrong here, drawing too much power somewhere. Oh, something went click. Oh, I heard a little tick noise there. Can you see that? That's down here. I can see some transistors were on as well, but here something's like 180 degrees. What is it? I think it's under the edge there. It's hard for you guys to see. Yeah, right here. I think this is extremely hot. It's blackened. Okay, let's see if we can just zoom in with the thermal camera. Whoa, yeah. Okay. That one. So there's a problem somewhere. That's probably feeding something which is short. And it looks like, most likely, it's coming through these 2 resistors here. Some sort of supply voltage. What voltage is on those? Let's have a quick look at that as well. In fact, if I measure the voltage on either side, I can work out the current, because I know the value of the resistor. So, looks like they're in parallel, actually. Yeah, it looks like they're wired in parallel. They're definitely wired in parallel, okay. I'll just power it up. We're on volts range. What do we have? 16 volts. And the other end, 8.6. Okay. Let's think about this for a bit. So, the voltage across these 2 resistors is 16 minus 8.6. The thing that's getting really hot down here then is this, which looks like a resistor actually. It has this glue on. Now this stuff goes hard and conductive. That could be the problem, but it isn't on the legs of the thing, and I think it's much more likely that's gone blackened because this thing is so hot, 180 degrees, okay. So this looks like it's part of the circuit that controls the protect the relay, okay. That all looks like it's part of this to me, most likely. This part down here looks to be basically the same as this part here. So this is probably part of the amplifier, NPN and PNP side. We have a similar group over here, okay. This is the treble amp. But I think that probably is part of that. It's a guess, the protection circuit. Let's have a quick look at the other amplifiers to see if they have a similar problem. So this is number 1, and I think, oh, interesting. So this one has been repaired before, I would say. This is the same resistor on the other one that's completely burnt up on here, and somebody has put a diode across there. It says 1012. Yeah, probably the diode that's marking the cathode end. So this appears to have a problem in the same area, but I suspect that this is burning up because of something. And here is the third one, and I think we have basically the same sort of problem. So it looks like these amplifiers may all in actual fact have the same fault, pretty much. I think on this one I can actually read that resistor. A bit hard to say, to be honest. Perhaps if I clean it up. Again, we have this like blackened glue. I'm wondering if this glue is part of the problem with these, you know. Although I wouldn't necessarily say on the first one it is. Yeah. I think we need to take one of these apart. We'll do the first one because we know that was glowing. But I suspect if we fix one, we quite likely know what's wrong with the others. Okay. Yeah, here's the first one again. I'm confident it's not the glue causing the problem, at least on this one. Let me see if I can actually read the value of this resistor. It's obviously not open circuit because it's glowing. Yeah, 180 degrees. It's going to be a fairly low value resistor, I would think, to pass that amount of current to glow like that. 52 ohms. I can see a green band here and a brown, so that would make it 5.1, so it's probably a 51 ohm resistor, so we know the value at least. I think I'm going to have to take this board off now to see what's short. So I'm going to have to dismantle this one. A bit of a pain in the ass, but I don't really see any other reasonable way to get at this. Okay, I have the PSU board off now. This is just the bridge rectifiers and the large capacitors. I'll just check actually if there's any voltage in any of these. I don't think there will be, but let's check. Yeah, that's discharged. Basically discharged 0.4 volt. Pretty much the same. Yeah, just very small voltages in some of them, 1.3. Okay, so there's very little voltage in that. Now we can get more down to it. So we can see all the transistors are soldered into the main PCB here. This is the burnt area, clearer now. Okay. I don't think there's going to be any shorts in these transistors because the main supply rails were up and I can't see any fuse that would be blown. Let's have a quick look though while we're here. No harm. This you would expect to be the base or gate. Reads like a transistor. This probably read quite low. Base emitter resistor, remember? This should read open. Pretty much, yeah. This is a driver transistor, I think. So this would read higher. We don't have that low value base emitter resistor. This is another output transistor. Well, that reads open. Is this a PNP? Do we have one NPN, one PNP? We might have. Yeah, we do have one NPN, one PNP, low value base emitter resistor, and with the negative to the collector reads pretty much open. So that's the first two we can see there and there. Then we have 3 big ones, okay? Yep. Yep, with the low value. And the low value base emitter again, 3rd one. Okay. And then we have basically the same sort of thing again. So I think we can see roughly how this is laid out now. This at the end, I'm thinking now we had 1 NPN, 1 PNP. So I'm thinking this, in fact, is the amplifier for the horn, the tweeter. Then we have 1 here with the large 3 transistors. Looks like a driver. Yeah, this one. Again, reads okay. There's a transistor here between the two. This might be like the one that balances up the 2 sides of the amplifier. Yeah. And then another one. This is probably the other polarity. So, PNP. Yeah. Yeah. And then we have the output devices, which will be the other polarity, I would think. Yeah, PNP. Again, with a low value base emitter. And the 3rd one. Okay. So, I think we can say high frequency amplifier. NPN and PNP, so that's just 1 amplifier with the driver. And then we have 3 outputs push the driver, NPN, 3 outputs push the driver, PNP. And this one, I'll just show you basically where that would be on an amplifier, just a generic amplifier, okay? So you often get in an audio amplifier, this is just typical example. Your output devices in parallel basically, there and there, okay? And you have your drivers, 1 NPN, 1 PNP, and then you have an NPN transistor in a circuit like this spread across the 2 bases of the drivers. This sets the bias for the amplifier to balance it so that when you have no signal coming in, you have effectively no volts on the speaker. So that is the other one I think I can see, or the equivalent of that, which is here. That would be fairly typical. So I'm going to get this PCB off. I really want to have a look to see what goes on here. I want to know where this connects in the circuit. I want to see if I can find any reason why that would be getting very hot. I think there's going to be a short in here somewhere. Okay. This could be a bit of a pain in the ass because I think these are all soldered in. I was hoping they were going to fit into like little slots on the board, but they don't. So I'm going to have to do quite a bit of unsoldering. Once we can get one of these off, hopefully we will find a common problem with all of them, okay? So I'll get this lot unsoldered. Now let's have a better look. Okay, I have the PCB off. This wasn't so difficult actually because the holes for the transistor legs are very large, slotted to make this easy, okay? So that wasn't too difficult to do. We can clearly see down here now, we can clean this up and we can get to the back of this and we can figure out, in fact, oh look, it's marked 50 ohms. So these are actually marked, that's a Zener diode, okay. We can have a look to see where this actually goes in the circuit. It looks like this is probably power. I'm just trying to figure out that end of that Zener. Yeah, it may be, just a guess, that there's power coming in here through the 50 ohms to the Zener diode, okay, and then maybe on the other side it is a double-sided PCB. That power then goes off into this lot. That was like a bad connection there. We can look around here for shorts now easily, okay. Very nice, all the components are actually marked with the type so we know what they are. That's really good. And the output devices, well, we can see them clearly now, okay. We can see what we have. So yes, as we thought, this is an NPN, this is a PNP, that's the driver, that forms the treble amplifier. We have the 3 here, 2SC6200, okay, 5200, yeah, I think it might be, yeah. Okay, we have 3 of those. We have a driver, we have another one which is the balancing one, we have the PMP driver, and then these will be the complementary of the other big ones, 2SA1943. And we're fairly sure that all this lot is okay. Yeah, the problem is going to be down in that area of the circuit. Okay, so we can see that the power comes in. I think it comes in here through the 50 ohm. That also goes to there. This is reverse biased. This is the positive end of this Zener, say positive, the cathode, and then the other end of that goes back to there, which I'm pretty sure is going to be ground. It makes some sort of sense. So the power's coming in somewhere here. Could be a short circuit Zener. I'm just thinking that's where this is in the circuit. The fact this resistor is getting very hot makes me think that's quite possibly what's happening. I'm just on resistance range at the moment with the bleeper. We have a short there, very low resistance, and that's a Zener diode, yeah. We don't have a short on that one. Looks like we have a shorted Zener here, or something else on that rail is short, okay. Let's see if we can just figure out where the power comes in and where it's coming from. So just looking at one of the other ones, I can see, first of all, that Zener diode has been changed on this without removing the board. And it looks like this had a problem in a similar area. In fact, it may still do, because looks like that resistor's also being changed on here and it's all burnt up. Okay, now we have a wire coming in here. So although this is actually a 3-way socket, there's a 2-way plug plugged in, and we have another one there, okay, which goes back under here. But yeah, I can see that one, and the other one goes into this. Yeah, it goes into here, and that connects the block. Yeah, it goes to here. This one, okay. This also looks like it's all blackened around these resistors as well. Makes me think these have probably all got the same fault. So we know from earlier, this connection here, this is the one which has a voltage on, but it's kind of like isolated. So the ground here is not connected to the main ground. These black leads, it's floating, and you often find that in circuits that control, or rather power, the protect circuitry. Okay, you can also see here that we have this device attached to the heatsink, which is going to be some sort of temperature switch, and that comes back to this connector, and this one goes into the 2-pin here, so that goes to some sort of sensing switch. Let's just measure that switch. It's either going to be open or closed, basically. Okay, so the switch itself reads quite a high resistance. I'm guessing that when that switch is on, it goes low resistance. Okay, like a switch, like a thermal switch. So that goes to there. I can measure that on another one of these as well if I want to be sure. So this is a switch which switches power into this circuit. You can see it does something, it sends some sort of signal in here. I mean, from what I can see, that just goes through a high value resistor. Is anything on the other side of the board? A bit hard to tell. I don't think there is. So that isn't providing power to something, it's just effectively putting a signal on here, basically some sort of signal, I would think, which changes when the switch opens or closes. Normally these are like a bimetallic strip in here, so it's basically a mechanical device really, like a thermostat. So KSD01F and then H090C, so probably 90 degrees C is the temperature this triggers at. The datasheet will tell us. And here we see it, so system tactile thermostat. It acts like a contact, as I say. It doesn't seem to mention whether it closes on heat or opens on heat. They do vary, there's different types, but not really that important. At least we know what it does. So that's here, that's like a switch. We'll assume this closes when it gets too hot, and it then puts a voltage on here. It gets the voltage from this point, which is the end of this zener. So whatever the zener is, 24 volt. The power supply, we know, comes in on these 2 pins here, which is interesting because all 3 pins seem to connect to somewhere, but we know that only 2 are actually being used. And it would appear that this effectively is the ground for this circuit. I would say it goes through the anode of the zener, which is where you'd expect it to go, and this must be the negative end of some capacitors. Okay, my guess is that the zener has gone short. Let's just lift one end of it. Is it short? Yeah, reads very low resistance. So the zener has gone. Now what's caused that to fail? Well, not much current can flow that way because it goes through a 10k resistor here. I don't think it goes anywhere else as I can see, so I don't think there's going to be any sort of problem down in that area. This diode is interesting. Where does it actually connect? Doesn't connect to either of those. Is it okay? Yeah, it reads like a diode. So this can only connect to something, or conduct rather, if this end is positive with respect to that end. Okay. And it doesn't seem to go anywhere here, not as I can tell. Particularly. Don't really see it. Okay. I think while we're here, let's just check these transistors and other diodes in the area. Okay. We have some low value resistors, but they are part of the amplifier circuit. These are the emitter resistors, and we have some more here, okay, for the other side of the amplifier. I'm sure this lot will be something to do with the protect circuit. Reads like a base emitter, maybe. Yeah, base emitter, base collector. Okay. The slightly higher reading is probably base emitter. That's a 2N255. Sorry, 2N5551. Another one here. Same device. Okay, so we go again. Reads okay. Reads okay. Let's just go emitter collector. Reads alright. Reads alright. Okay, what else do we have? This might be PMP. Let's have a look. Complementary. Let's see. Is it the same pin out? Nothing there. Nothing there. Oh, 717. Okay, that reads sort of like an NPN again. Hard to say about those readings, but I see another junction there. Looks okay. 9015. That reads different. Is this a PMP? Yeah, look. Opposite polarity. Okay, this is a red. This is another NPN. NPN. So they all read okay. So I'm just looking at this now. So this is where the connection goes down to that other board, to that zener. I'm thinking that's probably coming from these resistors. The two resistors in parallel. They're connected here. And read 50 ohms. That's exactly what you expect with 200 ohms in parallel. One end goes to here. Yep. And then the other end comes back into the circuit here. So there's got to be a diode or something. I'm not sure where this actually comes from, this voltage. There's a bridge rectifier down here, and there's a diode here, okay? And the diode reads okay. I'm interested to see if that diode actually feeds to these resistors of interest. No, it doesn't. Maybe it's this bridge rectifier then that feeds into that lot, but we can check it while we're here. So we can see the sloping end is here. So that'll be the positive end, and then normally the two middle ones are AC. Okay, and the other end is negative. Let's have a quick look. So sloping end is here. This should be the positive output. So we put the positive onto the AC terminal, should see a diode. We do. We do. And then this is the negative output, so we put the black onto the AC. We see a diode, we see a diode. And then with the positive to the red and black, that's the normal polarity. This should read basically open. I mean, there will be a capacitor across here, I would have thought. So that's probably what we see charging up, but that looks good to me. And this might be like a double diode in series. Yeah. Again, the capacitor's in there, so it's not really giving the sensible reading, but we can say that that reads okay. I think we've solved this. So short circuit Zener on the amplifier board down there. Obviously the current's flowing through the 51 ohm resistor, which is why it's glowing like a furnace, and that's also coming from this supply via these two resistors. Okay, so we know that's where it came from, and that's why they got hot as well. So I think that's pretty much covered everything. Let me see if I've got any 24 volt 1.3 watt or something. No, I only have 1 watt. That's basically the same size as the one that's fitted, the original one. Yeah, basically the same thing. I would have liked to put something higher rated in. I think almost certainly we have like a kind of a design thing here, so this is being pushed too close to its edge, and that's why it looks like these have failed on maybe all of these amplifiers. Okay, so what we'll do is we'll get one of these fitted, and then we'll put this back on. In fact, I'm thinking we'll get that fitted. We won't put this back on, but we'll power this up so we get some voltage into this circuit and make sure that not too much current's flowing anymore, but I'm confident enough that's it. Okay, we know the resistor is okay. I'll try and get this burnt glue off. It's probably easier if I unsolder this connector first, then remove the connector. Yeah, might make it a bit easier. Let's see if I can do it. I've used the vacuum desoldering tool. I think I've got the pins free. That one's free. That's free. This one isn't actually. Just go again on that one. Yeah, it moves. And it's coming off. Okay. This is definitely the easy way to do this, guys. Don't mess about. Think you'll save a bit of time and you won't, and you'll end up doing this anyway. Okay, now let's clean all this mess off. Yeah, that resistor isn't looking so good. Let's replace it. Okay, I don't have any 50 or 51 ohm resistors. I have 33 and I have 18. This is actually 33. It's just the colour balance isn't very good on this camera, but under the microscope we can clearly see. I'll just measure it anyway to be sure. So 33, and this one's an 18. So if I put the two in series I get 51, and that's good enough for me. Also, using two resistors like this effectively reduces the wattage dissipated by either one. So this is a very good way to do it. When I used to do this in the workshop, industrial electronic repair, and there was about 10 of us engineers there, we used to put serial numbers on everything we actually repaired when it went back out. And we had like a log, a book, so the serial number, basically, if you change something like that, I've put two resistors to make up one. Or for example, if you change the transistor and you put an equivalent, then you had to make a note in the book, so you'd specify what the original was and what you'd fitted and any other information as to why. That, I guess, was very good practice. I'm not sure it's quite so relevant when you're working on your own, but it might be, yeah, it might be. So it's one of them things to think about, maybe, is to keep a log. Because this is a bit of a pain in the ass to test, basically because I need to solder all these transistors back onto the board, I think it'd be a good idea to power this up and test it first, because I don't want to solder this all together to find I still have a problem down here and have to take it all apart again. So I think the best way to do this is to put this PCB back on here. This is the connection coming from the transformer, and we can see down here this is ground, and then it says AC 55 volts on both. So this is a 55055 AC supply, center tapped, the center tap being ground. So I can connect that to this PCB, put a couple of screws in so it doesn't move and short out. I don't need to connect the HT supplies to the amplifier anyway, the transistors are not in there, but I can connect this one that comes down. Okay, sorry, not this one, this one. Okay, I can connect that, and then this will power this part of the PCB up, and I can see whether or not we still have a problem, and I can also measure the voltage across that Zener. It should be 24. I've connected the light bulb over there, okay, in series with this, so just the power coming down here on that little 2-pin connector, which pulls into the 3-pin socket, strangely, but it's the same on the other ones as well. Just taking care that these don't short to each other or anything else, because these will have high voltage in them, that one and that one, because I've not connected the amplifier module. After I've done this, I'll have to discharge the main capacitors. They're very large, they'll have quite a high voltage in them. They won't discharge while the leads are like this, okay. So I've soldered a wire onto one end of the Zener diode, just so I have one hand free in case I need to switch this off quickly for any reason. That's the negative end of the Zener, so I'm putting the meter across the Zener. With that power on, the light bulb should flash, and this would say 24 volts. It does flash, but I don't see 24 volts. So there's something wrong here by the looks of it. Again, just make sure I had a good connection. Oh, something went click. It didn't like something, yeah? Did you hear that? Was that the relay? Let's go again. I can see the relay clicking, this one, so the relay is clicking. I just don't measure the voltage for some reason. My multimeter not working properly. Yeah. Just make sure I have connection to here by measuring the resistance to here. I do have. So the relay, the protection relay, is actually clicking. You can hear it, yeah? In fact, I think you can probably see it as well. Again, I'm across the Zener. Let's try. The relay clicks. Well, it didn't do that before, so I'm going to put this back together. So what I do need to do, as I mentioned, is discharge the main capacitors up here. You should find there's a high voltage in these now. So that's just into the black one. Let's have a look. Yeah, 67 volts. Minus 67. I made a capacitor discharger, you probably saw it a couple of videos ago. So here's the discharger that I made, so black lead into here, red into one of the other ones, and LED should light up. Yep, there you go. This might take a little while because I put quite a high value resistor in this. So this is my 18K resistor. I really need to put something lower than that in, to be quite honest. That's taking too long. Let's try the other discharger I made. So this is the one with a cheap multimeter, basically. DC range. Again, here's the leads. This has a 3.3K resistor, so this should discharge it much faster. $53, $50, $49, yeah, you can see that's going down. Okay, so these are all soldered in now. We just have a look. All looks okay so far. Oh, a bit of solder down there. Get rid of that. I probably should get some thicker solder actually. This stuff is a bit too thin for this sort of work. This is 0.6mm. Let's get out of the way. See where it went on my bench, okay. Let's just check again. Okay. I've connected this up now, so it's connected to my mixer. I'll just turn the input signal down for the moment. So I have the horn amplifier connected to my full range speaker. I have the bass amp connected to my sub. So we have the current limiting light bulb on. Let's see what it does. Well, bright then dim, so that's a very good sign. So I'm going to switch this on. We can watch the lights on here. What do we get? We get on and the relay went click. Let's see if it works. And apparently no, it doesn't. Yeah, I have a signal on the mixer but nothing coming out of this. Let me just try the other lead. Well, that relay is definitely clicking, but I don't see the signal light on here, okay? Could be a problem with this, I guess. Okay, back in, let's have another go. So, volume down on the mixer. Power. Relay. Nothing. Okay guys, so this one isn't fixed yet. We've made some progress, I think, at least the relay clicks now. But, well, I did actually think that was going to work, yeah. Well, I've just noticed, as I was just going to finish it, the volume here has actually turned all the way down, yeah. So let's turn that up. Let's turn the mixer down again. And let's give it another go. So, power on. What happens now? Ah! Yep. So that just goes to show, guys, how in the end something really simple can fool you. Yeah, that's good. So it does work. Right, quick check, and we're going to end this video now. But I'm just going to have a quick look at the other ones to see if they have the same short that this had. Here's number 3 then. Just zoom in a little bit, let's have a look. So there's the Zener. The resistor's kind of tucked back under there. It's not as burnt as the other one though. So let's see if this one has the same problem. I'll just go forward biased across the Zener. And it reads 702. So that's a good Zener. This doesn't have the same fault. And here's number 1. And we can see with this one that somebody's fixed this before. So that's the resistor and it's all burnt up on this one. Okay, very burnt. And then this is the Zener. That reads short. So this appears to have the same fault as the one I've just fixed. We're going to need another video to look at the one with the different fault. You can see what somebody's done to this. Okay, so they've taken out or cut off the Zener. They've done the same with the resistor. So this has been repaired by attaching components to this side of the board rather than what I did, which was to take the board off and do the job properly. Yeah, okay, fair enough. I also wanted to diagnose it, but here's a question for you guys. If you were doing this repair on this one now, what would you do? Would you take all this off, unsolder all the transistors and fix it like I fixed the other one? Or would you just be lazy and do this? Yeah. And if you would or if you wouldn't, do you consider that to be a professional repair, or do you consider that to be a bodge job? Down there. Answers. Okay. So we'll have a follow-up. We'll fix this one. Let me know which way you think I should do it, and then I might just do my own thing anyway, or I might not. And let's have a look at the third one to see what fault is on there. Okay, hope you enjoyed that, and I look forward to seeing you all again soon on Learn Electronics Repair. Ciao for now, guys.